Okay, so optimization problems is something just absolutely neat that we can actually solve with AP Cal. Well, any kind of calculus, but optimization problems are the big ones. Okay. All right, so let's take a look. Okay, we need to enclose a field with a fence. We have 500 feet of fencing material and building, and a building is on one side of the fence, so we don't need any fencing on that side. Determine the dimensions of the field that will enclose the largest area. Okay. Alright, so we have 500 feet of fencing material and a building is on one side of the field. So if we take a look at it, okay, so here's our building, okay, and we have over 500 pieces of fencing to use. Oh, there we go. Alright, let's go right here. Okay, so we could have this much fencing, we could have this much fencing. Well, shoot, we probably won't use that because we want to use just the building as the side. We could have this much fencing, but either way, we need to have 500 feet of fencing material. Okay, all right. Determine the dimensions of the field. Okay, so like any problem we just need to work with, we need to actually come up with some formulas. Okay, so we want to maximize our area, which is equal to x times y. Simple as that. Okay, and the only constraint we have is going to be 500 feet of building materials, and we're going to have one side, okay, plus two other sides. Now the reason why I'm not adding up 2x plus 2y is because one side is just going to be a building. Okay, so what I'm going to want to do is solve this equation for x first. Okay, so I just set it up. I'm going to go 500 minus 2y equals x. Okay, now that I get that, I can actually plug it into this equation and get 500y minus 2y squared. Okay, now that I actually have this equation set up, I can start to do some stuff with it. Because what I can do is I can actually, let's go ahead and do it. Okay, I'm going to go ahead and actually do the derivative of it. So I'm going to do the derivative of area and get 500 minus 4y. Okay. Okay, now the reason why I'm going to do it this way and do the actual derivative first is because if you remember, okay, the actual mean value theorem, or sorry, not the mean value theorem, Rolle's theorem, okay, which says if these two numbers are equal, okay, then somewhere in between the derivative have to be 0. And guess what? The derivative is going to be at the absolute max. That is a gorgeous thing right there. I don't know if you guys are excited as I am, but optimization is just a gorgeous thing to work with, especially when you know all your stuff. Okay, now, what 2 points are we going to be looking at? So the 2 points we're going to be looking at right here are going to be, the 2 points that we're going to be looking at as our interval is going to be 0 to 250. Now, why 0 to 250? Well, if we use 250 for the two sides, so for example, if 250 was y, okay, that would mean the sides of the barn would be still just x. Okay, so it would be 0, and so that gives us the least amount of area, but that actually occurs in two spots. It happens when one is one side or the other is the other side. Okay, so what we're going to do is set this up to equal to 0, and then we're going to find out that this actually becomes y equals 125, and that's one of our critical points. Okay, so if you think about our actual picture right here, so we have our actual box, which is going to be our side, and then we have our actual side. Okay, so if this is y, and this is y, and this is x, okay, that kind of makes sense why it works that way. Okay, so this is 125, and this is 125 as well. Sorry about the extra large marker. Okay, and this leaves this to be 250. that will give us our total fencing to be there, and it'll actually give out our area to be, I believe, about 31,250 feet squared. Okay, so, or square feet, and that should be a comma right there. I'm not European, so I'm not using that. And because since I've worked this out and I know that this is the critical point, this is going to be the highest point when the derivative is 0, okay, I know that this has to be the max area. Okay, so the dimensions have to be, for this problem, is x has to be 250 feet and y has to be 125 feet. And that will give us our maximum area, and with the dimensions being the highest they could be. Okay, so remember, once again, try to find the formula you're trying to maximize, know the constraint, plug that constraint into your maximization formula. Okay, try to get in terms of y or x or whatever letter you want to solve for, and then get the derivative of that formula. Okay, set it equal to 0. Why? Because we want the point of absolute extrema, and then solve it equal to 0. Okay, solve for that letter, that plug in your numbers and double check it. Okay, and just remember, these are endpoints. We don't want to use this interval. We don't want to use the endpoints of this interval because it just makes it that much harder to work with. Okay, all right, but that's it for optimization. Just take your time, do your derivative, and make sure you have a maximization and constraint equation. Thank you very much, and have a great day. Bye.